All right, so we want to look at a simple unit conversion problem, and for this one we want to convert 0.112 milliliters to nanoliters. My advice on this is to take a two-step process. First, of course, we want to start with what we know, and we know that we have 0.112 milliliters. We can convert milliliters to liters. We know that 1 liter contains 10 to the third milliliters. Of course, milliliters will cancel. And then we know that in 1 liter, there are 10 to the 9th nanoliters. And now liters will cancel. Ten to the 9th divided by 10 to the 3rd is 10 to the 6th. So that's 0.112 times 10 to the 6 nanoliters. We need to convert that to proper scientific notation. We'll move our decimal point one place to the right. So we'll reduce our exponent by 1. That gives us a final answer of 1.12 times 10 to the 5th nanoliters. And of course, we want to box our answer since that is our final answer. So let's try another problem, and this one is a little bit more difficult. We have a density of 0.0345 grams per milliliter, and we want to convert this to kilograms per cubic meter. This is a problem we've discussed quite a bit in class, and it still is giving people a lot of trouble. So let's take a look at it. So of course, we want to start with what we know, which is 0.0345 grams per milliliter. If it helps, you can put 1 milliliter in the denominator. I'm going to convert grams to kilograms. I know that there are 10 to the 3rd grams in 1 kilogram. That allows grams to be canceled. I know that 1 milliliter is equal to 1 cubic centimeter. This is a conversion factor we've discussed in class before. And if you need to, put that in your notes. I would highly recommend adding it to a flashcard. And the last step is the step that usually gives most people the most problems. And that's 100 centimeters, 10 to the 2 centimeters is 1 meter. But I need cubic meters, and I have cubic centimeters, and that can't cancel with a centimeter. So I need to cube this conversion factor. That allows cubic centimeters now to be canceled. And I'll have cubic meters in the denominator, which is precisely the unit that I want. Now I have 10 squared to the 3rd power is 10 to the 6th. Remember, I multiply those exponents. 10 to the 6th divided by 10 to the 3rd is 10 to the 3rd. So 0.0345 times 10 to the 3rd simplifies to 34.5 kilograms per cubic meters. I could also write this as 3.45 times 10 to the 1 kilograms per cubic meters. Remember, our self-imposed rule is if it's 10 to the third or higher, we will always use scientific notation. Or if it's 10 to the third or lower, we will always use scientific notation. You really have a choice when the exponent is -2 to +2. This exponent is a +1. Therefore, I would report this as an ordinal number, a non-scientific notation number.